All right, I think I'll just introduce myself. My name is Andrzej Krzywda. Today I'm in two roles because I'm one of the organizers here, and now I will have my talk. So as an organizer, I would like to welcome all of you. And as in every edition, I'm very, very grateful and very happy that you have come here and that we can meet with so many passionate Ruby programmers. I think this shows the power of Ruby, so thank you very much for coming. My talk is kind of like a story about my journey in my programming hobby, passion, and programming career. And I want to show you how I think about code, how I think about business logic. And I want to show you some examples of the code. And I would like to invite you also to share some of your ideas with me. So just to give you some context, and warn you, the next slide can be offensive in the Ruby community. So this is a warning, because it contains Java. And this is my introduction to you, and this is my coming out. I was a Java developer. And I was part of the Java community before I started doing Ruby. And I was part of this specific part of the Java community, which was all about Agile. But Agile 20 years ago didn't mean meetings yet. It meant more about caring about the code and expressing the business rules in the code base nicely, and about unit testing and so on. So it was all about really very code-specific things. And I'm talking about the Java background because there was a very strong thing in the Java community. So, okay, the warning was there. Let's look at some code. Java. Who can tell me what is on this code, what this code is about, or what is the example? It's an implementation of a post class, right? Similar almost to what DHH shown in the initial Rails applications. What is specific here is that this Java code doesn't use any framework or any library. Do you know how in Java community we called those kind of classes? Pojo. Plain old Java objects. That was an important thing in the Java community. And the idea is that we have business classes which are not bogged down by framework extensions. And 20 years ago, there was really not much about frameworks in the programming community. It was more like libraries. But it was considered to be a smell or a bad design if your business classes had imported in Java or used any kind of extension that was coming from the outside. The business classes were meant to be pure and not infected by any library. So when Rails appeared, when Ruby on Rails appeared in 2004, a big part of the Java community was excited, and I was part of this Java switch as well, and I was one of the Java people who switched to Ruby. We got excited because Ruby community was so much about testing, unit testing, care about code quality. The language, the syntax was so elegant that it was almost like we wanted to do Ruby in Java all the time, but we just didn't know Ruby existed. But the problem is that when DHH was selling us the idea of Rails, and we kind of got seduced to Rails from the Java community, we bought all the nice things that were coming with Rails and Ruby, but we also bought one thing that was probably just by accident, or we were believing that it's not a big deal. We bought inheriting from ActiveRecord base. So when DHH was showing this code, and that was kind of like this, but shorter, we were all like, oh my God, this is shorter, so this is better. So now our communication with the business requirements, even with the business people, is easier because they can even look at the code and probably understand maybe apart from the ActiveRecord base part. But what DHH nicely hid from us was this, because this is actually what the code is there, maybe without the inheritance part. So we have readers in Java. We call them getters. There is some setters as well. There's a constructor, And at the end, there is this is like more like pseudocode. This is not exactly what ActiveRecord does, but this is more like what we actually do when we inherit from ActiveRecord base. And at the end, we have the coupling to the database. And that was a big deal. That was a big deal for the initial Rails developers, that it's so easy to use that the database is already part of the ActiveRecord, but we bought it and we were like quite excited. It's not a big deal. It's not a big deal. That was always the something that we have repeated. It's not a big deal. We are depending on database, but it's okay because this code is so cool. And then we understood that we can write even nicer code. So if the post has many comments, we can say it like that. And the validations are super easy to implement. So we were like excited that it's all there. And we didn't realize probably at some point that we can split those objects. So each ActiveRecord object, and that was kind of this is now part of my journey. I switched to Rails. I really liked and enjoyed the Ruby code. I didn't like the ActiveRecord dependency more and more over time, but I still wasn't prepared really. How can I rescue? How can I escape from the ActiveRecord dependency? So it was a long process, actually, many years of experiments, discussions, what I can do with this code, because obviously if the code is so simple, then everything is great, but we all know here, those models never end like that. They always end like 500 lines at least. So one of the biggest realizations, I don't want to go too deep into the splitting between reads and writes, but because my next part of my talk is based on just the business logic, so which means only making a decision in the code base, I don't want to be bothered about getters, which are actually, this is what is ActiveRecord about. It has two roles, reads and writes. And reads, so writing data is making the decision. So are you accepting this as a new title for the blog post? Yes, validations are passing, so this is fine, we're accepting this. And reading the data, so for example, has many comments. This is an association. In most of the situations where you use associations, you use them for actually showing the data on the screen later on than making the decision. You don't care if you are changing the title, you don't care how many comments are for the blog post, you're not making a decision based on the comments. But now with the has many comments, you have quite a big dependency and coupling to comments. And I think it was Markus, who just ran the mutation testing workshop, who first told me, so I'm quoting him now, that ActiveRecord has an infinite API. So once you inherit from ActiveRecord base, your models has a really infinite number of methods available, so your interface is huge. So how can we get rid of that? The algorithm is more like that, split ActiveRecord into two objects. Readings disappear for one of the objects. So one is about writing, second is about reading. The readers disappear, so including associations, and only logic is left and publishing events. And introduce read objects just for the sake of displaying data. More or less, how does it look in the code? You start with this, then you implement the business logic in a separate object. Now, note that there is no ActiveRecord dependency anymore, and you just have, for example, the part where we say that, okay, we are not accepting a post without a title, so just raise an exception. And the second part is about publishing events, because that's the only way those two parts can be connected in an easy way, where you make a decision, you publish an event, and the read object can accept it, and I'm showing the read object. And the read object actually is ActiveRecord, because ActiveRecord is very nice for displaying data, so that is okay. And it's very nice for using associations for that, if you like. So if you just want to display one single blog post with their comments, this is a really good code. And now, connecting together, you say subscribe, post, drafted. So the part that happened in the writes on the decision-making process now influences the object in the ActiveRecord object. And this is more or less the algorithm to just make your ActiveRecord immediately smaller by 80% because you no longer need the readers. Okay, but this is a trivial example. Let's try to think about some more complicated situations. And it happened that at Arkansas we've had many hours, years of internal discussions how to implement business logic. So now I'm focusing only on business logic here. And we've had many discussions with everyone who was willing to talk about how to implement business logic. We adopted domain-driven design, and we call them the business logic classes. We call them aggregates, but it doesn't really matter. This is not a talk about domain-driven design at all. And it happened that at some point we have started a Rails Architect Masterclass. It's a class for people who want to understand the DDD and CQRS and so on. And thanks to this, a new repository was created internally at Arkansas. It was a private repository. And that was a repository created by Pavel from Arkansas. And Pavel decided, okay, enough talking about different ideas, how to implement business logic. Let's actually implement it. And let's see how the different implementations can look like. So Pavel created a repository called aggregates and started implementing some techniques how aggregates can look like. And I really liked the idea, and the repository was really nicely constructed that you can easily add a new implementation. There are tests which are shared for all the implementations, and you can easily add a new one and just see the tests are passing or not and just finish the implementation. So for the same example, we have different codes overall. So all the structure is there, but the nicest thing was that Pavel discovered a really nice requirement which we now started using for non-trivial situations. So we don't want to talk about blog posts because they are not really about business logic that much. We want to talk about, who can guess where it is from? Jira. We all love Jira, right? So this is Jira. This is actual implementation of Jira. And what can be more realistic than Jira to implement business logic, right? And business people love it. So even if you want to share this code base to some business people, they will understand what is Jira about. And Jira issue has those states, and you can, this is the life cycle of a Jira issue, and you can transition between the states. So business logic here relies on a state machine, and actually this is kind of my thinking right now, that business logic is almost always about state machines. And I see state machines now everywhere, so yeah, I will not go that much. Okay, anyway, there are some rules about the state changes, so you can see it's not a trivial example, it's a realistic example, so how can we implement this? And one of the first implementations was based on aggregate root. For those of you who don't know, we have released Rails Event Store as our library for using events. And there is this aggregate root gem, which helps you building event-sourced aggregates. However, we are not really caring that much today about event source, so it's all about event sourcing. So it's all about just, I want to show an example how the implementation of the requirements would look like with aggregate root. And I will start by showing the slide with a code, I hope it will be clear, which just shows how the aggregate is called, how it is used from outside. Can you see it from the far? Not really. Okay, I will not, this is just, a command handler / service object of using the aggregate.whatever method, but I hope this code will be clearer. So this is the actual aggregate, and my aggregate is so big that it fits into 3 slides. So this is just the first part of the aggregate class, and it's called, so okay, we have the class issue, we have the public methods for creating, resolving, closing, reopening, start. All the transitions that are possible in the diagram are represented here as public methods. And there is a certain structure. We raise an exception unless it's possible to do this thing. And it's possible to do this thing, and the implementation actually lives somewhere in other methods called like can close, can resolve, can create. Right? And then we publish an event. We publish an event because, as I showed before, we need to have the data available somewhere else to just display the data. So we need it for the read objects, for the read models. So this is the second part of the aggregate. Now there are the private methods where we actually check when things are possible. And as you can see, it's mostly about relying on what is the status field. So we have an instance variable called status, and now we know whether we can do something or not. So that's the second part, the actual implementation of those steps. And then there is a third step, and this is just a logic for saying how the issue can be built from the events. So when we are changing the state of the events and we want to bring the state again of this object to the same level, we are building this using those events, and we know that for this event we are changing the state to this value. One problem with this code, so I'm going back to slides, is that we are including aggregate root. And even though it's our gem, one of the problems which I showed you, I come from the Java community, we cared about plain old Java objects, no imports, no libraries, no frameworks should infect our code bases. So even though I prefer this code to implement business logic more than typical ActiveRecord in typical Rails way, I would always go with this code over the ActiveRecord. I knew that there must be something better where we don't have to infect our code with the aggregate root. Even if aggregate root is actually, I don't know, 4 methods. We are just injecting 4 methods. Still, it's a library. We shouldn't use it in business objects. So that was my challenge, how we can do it. And it was nice because last year, maybe some of you remember, Nathan came here, and Nathan had a really interesting talk about aggregates, and he was talking about the problems with aggregates, and he was showing that this pattern is maybe not the most elegant pattern that we are coupling the business logic with events. And that gave me quite a lot of thinking. I spent a lot of time discussing this with Nathan, discussing this with Pavel, discussing with Robert. So we've had many discussions how we can maybe avoid this situation. Okay, so what is the summary of this implementation? It's a one class, the issue class. It contains the decisions-making process, though the logic. It contains publishing the events. It contains sourcing from events, the last part, and we also keep the state. We have the status instance variable. All right, so I'm going to show you now. So we've had, in the repository, we've had like, I don't know, 7 different examples how we are approaching this, and we were influenced by, there is a programmer from Poland, from the .NET community, Szymon Kulec, and he's had a nice series of blog posts how we can implement aggregates in a functional way. So we were also experimenting how we can do it in a functional way. But then one of the inspirations, which was also like for me from Szymon, was the idea of a polymorphic implementation. So I went with the polymorphic implementation. And what is specific about polymorphic? So here is again so maybe here is more visible, the command handler, but it's like in all of the implementations is the same, how we call the aggregate, so there's nothing really interesting that much. However, in the previous aggregate implementation, in the code which was so small that you didn't see that much, it didn't have the part about events here. So now I moved the events to be part of the command handler, so that I don't have those events as part of my business class. And at the end, so I'm always calling the issue.start or issue.close, and then if everything is fine, I'm just returning an event. That was something that actually for a long time I didn't know how to solve, because I wanted to decouple my business logic from events, but I just didn't know how can I communicate when something worked or not. But then I realized that if I just call a method on an aggregate, let's take the first one, issue.open, if it didn't raise an exception, it would execute the next line. So I know it's successful. I just know it by not raising an exception. So then I know that it happened, and then I can actually publish the event. Okay, so this is the event sourcing part, because now it's not part of the aggregate, it's now part of the command handlers infrastructure code. So for each like the changes of the state, I'm now calling the building the object from the outside this time. It has some limitations, it has some drawbacks. I will come back to this. So this is the implementation now. This is the polymorphic implementation. So now instead of one class called issue, I now have a class for each of the possible states. So that was a new discovery for me, that I don't need to have one class. I can implement it using several different classes. The second influence from functional programming was that I can return, when I'm changing the state, I can return a new instance. That's what functional people do. They don't mutate the state, they return new data which is already changed. So when I have just the issue in the initial state, I can call open and I return the open issue implementation. So I'm not sure if the naming is good, like maybe I should call it open issue instead of open, but just I liked it to have it short. When you have the open issue, you can start or resolve or close. But other operations are not possible. So I'm raising an exception, right? And then this works. So there are 5 states, which means I have 5 classes, and they all allow me to see the code and the changes in one place. I don't care about events, so I'm not bothered by events anymore. I'm not bothered about building from events anymore. So what happened? I have now one class per state, and each state has their own decisions, right? What is possible to do. Then in the command handler, I'm publishing events and building and sourcing from events. So now I have moved the responsibilities. And you could say that I'm complicated the command handlers at the cost of the business logic in the business class, but this is what I care mostly about. I care about the business objects being pure and not infected by anything else. I just want to see the business logic in one place, not be bothered about events or persistence or anything like that. And what is now also interesting, this is the functional influence here, is that the state, as in it was previously, it was called status. This field, this instance variable, it disappeared. Now the state actually became part of the type. So using the type system, I have now encapsulated what is actually the state right now. And I really like this the last thing that I can now use it like this. But if you look at this kind of code, and you're a Ruby programmer, then it kind of screams. What would you do with this code base? Delete. It's not Java to delete. Meta-programming, yeah. What kind of meta-programming can we approach here? Given you're laughing now, I'm scared to show you what I did. Any other ideas? Maybe I can quickly change direction. DSL, yeah. What would DHH do? Inheritance, or acts as invalid transition, maybe. Okay. I called my next implementation duck typing. This is the command handler part, not really that different from the previous one. It contains the events, so it's very similar, but there is this new line. I actually, in my original implementation, I went for the no method error, but then I ended up re-implementing this, and for those of you who don't see it exactly, there is something like raise invalid unless issue responds to stop. So I'm using the respond to method. I'm checking if this Ruby object knows how to respond to this method that I'm going to call. My first implementation was trying to call the method and then rescuing from no method error, checking if no method error actually failed because of this specific method doesn't exist and not because of some typo. And it was also working. But then I thought it would be too controversial, so I went with respond to, which I'm not like super happy about, but it's probably okay. So just a reminder, this is just my academical experiments. I'm not suggesting we should use it. It's just I want to show you what is my journey in discovering what is the business, how the business logic can be implemented and extracted from everything else. Okay, so what is now the business logic? How does it look? This is like still the command handler part, and now this is the whole implementation of this diagram. So now we have 5 states, 5 simple classes. Instead of those methods which raise exceptions, they just disappeared. I don't think we can call it polymorphic any longer, because polymorphic means that you have different objects using the same interface. But now we have classes which don't have the same interface. And this brought me to thinking, when I started doing Ruby, it was all about learning about duck typing. But when I work with Ruby code bases, I either don't see any kind of duck typing, or I see really, really wrong usage of duck typing. So I wonder how much we really want to adopt duck typing as a technique in the Ruby community. Like under very controlled environment, like this state machine, for example, I am okay. After a long struggle, after a long thinking, I'm okay with this code. But I know some people were laughing. I remember who was laughing, actually. And I know that this is not exactly something that can be easily accepted, and it's something that I'm still not sure I will not hate myself 1 year from now. So maybe in 1 year we'll meet again and I will tell you this is wrong. But this is why I went. And I'm showing this example, and I know it's overall simple, but a reminder, business logic is mostly about state machines. All state machines can be implemented like that. It doesn't require any library. I'm not selling you any library, any framework. So if we can start and explore how we can implement state machines in Ruby without libraries and frameworks, how we can make it even nicer without any, not feeling right about it. Maybe I'm using duck typing and this is wrong. So I think it's worth it, because if we can reduce all the problems to state machines and we can implement state machines like that, and we can attach our persistence later, either via events or just a traditional relational database persistence using ActiveRecord, it doesn't matter. I can just plug it, connect it later. And that's what I wanted to get. The last thing, I told you that the repository was private and was used for the Rails Architect Masterclass. I've made the repository public just 1 hour ago. So I would like to invite you to go to GitHub and RKNC aggregates, look at the implementation. I'm really, and honestly, I'm really open for new ideas and contributions. If you know how to implement it better, I would like to see a different implementation. And it's very easy to add a new implementation. Just go there and copy one directory with the implementation. Look at the make file. In the make file, just copy one section to create for the new implementation, and just try to explore how you could do it with passing tests. As a bonus, this repository is also set up to use mutation testing. So there is a script for mutation testing. So if you enjoyed the mutation testing workshop, you can run mutation testing against your implementation. What was really nice about this implementation, the last one, so the duck typing one, we can probably agree that the code is quite abstract and high level. And using mutant on this code base was really interesting experience, because it showed me a lack of test coverage, obviously, but actually what it showed me is that certain of those states are actually kind of duplicated. Basically, mutant told me that the Jira is wrong. The whole state machine is not correct. So it was a nice experience to run it against mutant, and your implementation maybe can also you can use mutant and see how it works. Yeah, so please contribute to implementations, and also if I was wrong somewhere, if you see that you can correct me, feel free to come to me during the conference. I'm open for new ideas. And thank you very much again for listening to this talk, and thank you for coming to the conference, and enjoy the conference. Thank you very much.